titled Spotify in Python, Love at First Sight. I don't know actually who named the talk. Was it you, Per? Yeah, and I thought, okay, yeah, I can do a talk about this and how it fits. But first, who am I? Why am I standing here? My name is Åslund. I'm from Sweden, and I'm very tired. I didn't sleep much last night, so if I fall asleep, can someone please wake me up, because I've got about 30 minutes to finish this, and I got 70 slides. But it's going in this speed, so. And like many others at Spotify, I studied computer science at KTH, the Royal Institute of Technology in Stockholm. And I'm not that famous, but if you know me for something, it might be Shakespeare programming language, a toy language I created together with a friend that I studied with at KTH. But I joined Spotify autumn 2006, so it's pretty early. But Spotify itself, the idea started in April the same year. And the story goes something like this. These guys, the founders, Daniel and Martin to the left, they were, I think they were at Martin's place because it was his birthday. And they wanted to listen to some music. And it was pretty hard to find some music. Like they were rich people, they didn't go buy on the stores, but it was annoying and slow, and it's like, it should be much better. The technology was already there. Someone just had to piece it together, and so they decided to do just that. This is a quote from David Bowie, that music itself is going to become like running water or electricity. And Daniel believes that, and he believes that this is how Spotify should be. It should just be like a stream of flowing music. And when you think of music on the internet, you think of Spotify. But in order for that to happen, they needed to have some reference implementation. So our first goal was to create a native desktop client for Windows specifically, even though this looks like the Mac version. And Daniel had worked with Skype before, so he knew the power of a good native client, and the user experience that you can do with a native client, at least back then, was much better, even though the web already back then, that was the future, but good native desktop client. But that's not enough. Like, if you should be able to stream music anywhere, you should have like a mobile experience. So we focused on mobile as well very early, even though the iPhone itself didn't exist yet, but we knew Apple would come and save us eventually. And also, third-party vendors should be able to implement Spotify in their devices. This is the Sonos device in someone's really fancy bedroom. And one of my favorites is last year, the science student called Jordi Parra. He created this as a sort of thesis project with this. That's like Spotify box, and it looks awesome. And like have these RFID tags you can just attach to it and playlist and everything. And this is like grandpa compatible. This would work. But so that was the vision. So how far did we come? Yeah, all of these things, they're already implemented. And now in June 2011, we have over 10 million users, over 1 million paying subscribers, and we exist in these 7 countries in Europe. Unfortunately, not this one. Yeah, and the next we're going that way soon. And then we will come back and cover it and make Europe more real. In the library, there are over 30 tracks. I think it's actually closer to 40 now. And we have over 300 employees, so we've grown like crazy. And half of them are in Stockholm. And almost soon 100 work in technology. And not all are developers, like some are operations, QA testing, product dev, designers, and so on. But we're a very heavy technical-focused company. And yeah, so we need servers. So we have over 600 servers in 3 data centers across the world, like London, Stockholm, and somewhere in the United States. And we use Python everywhere. So let's go back to the beginning again, when I started, and then where did we start? Well, we had the rough idea, the Windows client thing. That was important, and it should look something like this. This is actually the first, can you see? Yeah, the first draft sketch of the client, in Paint, or as you say in Sweden, Windows vanliga program. And here, this is Swedish, like ads, köp means buy, so you should have ads in the client, and more ads, and there's a playlist, and more playlists, and here's the list. There's a pause button, you can pause music if you ever want to do that. Then there's a search box up top there. So this actually looks like the client that we have today, and we haven't changed much. The only thing I recognize is that the mother library. It says we don't have that. You have your friends list there instead. But otherwise, it's the same thing. And we didn't know how to code Windows at all. We were like, we're studying computer science. Like we were all Unix people. And so we hired one developer called Ludwig Strigius who wrote uTorrent. And he knew how to make a good Windows client. So then we were back. Oh, sorry. Yeah, I should make that one. There. Can you still hear me? Good. So we were to create the backend while he was focusing on the Windows client. And the only sort of idea that we had was that we wanted to do the Unix way, like build many tools that did only one thing really well. So if we can turn on the laser, yeah. So search, we wanted to build a tiny search service. Playlists, we wanted to build a playlist service. Ad service, and you should be able to stream and play music, of course. And that's about it. That's what we want to start with. But we didn't actually decided to use Python. That was not our philosophy. Our philosophy was actually more getting the right tool for the job. But then it turned out that Python was really, really great tool. It was very tiny and cute, and we liked that, and it fit with our goal of writing tiny services. And also we had heard of this great framework called Twisted to write network services. And this is great. So even though we hadn't actually had any great Python experience, like most of us had touched Python, wrote some scripts, but not in a big way, we bought the Twisted. Let's learn this for real. And we came to the foreword, the glyph wrote for this book, and he started talking about how great Twisted were, and suddenly, hey, there's a squirrel! And we thought, what? Oh, look, it's eating peanuts, and weird. And then we're like, oh, he's so funny. Like, before we even had started reading the book, this was the framework for us. So we loved it. So then we started implementing. So here you can see a sketch of the back-end architecture. So look there. From the client here. And then we started writing a logging server. And if you see the color here, it's blue-purple. And as you know, that means PHP. So, why did we write that? Yeah, it was our art director. He was like, I can write the login server in like 2 hours, and he did that. But then we were like reading the Twisted book, and like, no, let's switch that. So we switched pretty immediately, and that felt great. Like a simple Twisted service, talking to a Postgres server, and it just worked. But we were not done yet. We had to do search as well. And it's pretty easy to write like a full text search implementation, but there are already really, really good implementation out there, and one is called Lucene. And it's written in Java. So let's Java, put the Lucene library in a servlet, wrap that in Tomcat, and off we go. We have a HTTP server running Lucene, and we have a search server. And so now we have 2 services, all talking HTTP, and one is written in Twisted and one is written in Java. That's fine with us, and then Java is red here, you can see. But we're not done yet. We should be able to listen to music, so we just put an Apache up with some MP3s on it. So that's it. That's the basic architecture. And already at this point, Lud had finished most of the client for these 3 systems, and you had a usable system that we actually liked. We were not done yet. First, we inserted this thing in the middle here. It's called an access point. Why did we do that? Well, we started getting, even though we were like 15 users at the time, we started getting lots and lots of connections to all the different backend systems. And handling authentication with all of those, that's not what we want. So we put this thing in the middle, which handles authentication, and since this is really sort of a network proxy service, Twisted fit perfectly. It's like, yay! And like, power of squirrels, we could actually do this, and you have the ability to write your own protocols and everything. And the essential idea of the access point is to, so let's go on the laser again. Zoom. Go here, forward to user, log in, and then you have a state kept here, which knows that this client is already authenticated, and then these tiny services here can be tiny, you don't have to handle with authenticating at all. And also we built our own protocol with the client, so you can have an open TCP connection, open at all times, and only one, so we had sort of a multiplexing thing there, and it helps great for latency issues and link connections. But we're not done yet. Playlists. We want a playlist as well. And it's green, so that means Twisted and Python. And it fit perfectly again. And this time we wanted the user experience in the client to be sort of, you shouldn't even notice that you are talking to this backend server. It should be like locally create a playlist, you drag and drop, rearrange, and then eventually if it's online it will sync. Which then means if you have 2 clients, one is offline and one is online, and then you merge, you get these weird merge conflicts, and so we solved that as well. And it turned out we actually built a distributed version control system by accident. But it's fun. I'm interested. But more. Oh, it turned white. The access point turned white. Yeah, it's actually the reason it turned white was because we moved it to C++. Not actually because of performance reason, but more of we hired a new guy, and he's like, yeah, I can write this in C++. Why would you want to do that? Because it's fun. Oh, okay, you go do that. And he did, and it's really great. And so in hindsight, now we can handle a few more users because the CPU usage in Python isn't that good, but I'm not sure we get 70,000-ish users per access point machine, something like that. But anyway, it was more of a choice for the people who implemented the service. Like, what language do you want to use? Like, can you motivate it technically? Is this good reason? And it was, and it did. But we were not done yet. Add service, show ads, that was main goal to begin with. And we want this to be an ad funnel service, so we wrote it in Twisted. And there's more. Like, I don't even have the name of this one, but it might be the tracker. We have a protocol, looks like it's like a BitTorrent-ish, and there's a tracker, and there's I don't know, more download service storage, and there's more and more. Some are written Java, and most are Twisted, and it's like mostly super good. Right? Like the bubbles here. This is sort of the view of the different languages and frameworks used in our backend system. And all of these I call core services. And a core service is something that if one of them goes down, the functionality in the client will be reduced. But it's not like it's the end of the world. If one system goes down, that part is no longer usable, but the rest works. And that's one of the main goals of the backend architecture, that tiny services shouldn't affect the rest of the system. So if that instance, access point goes down, that's really bad. But then the client just connects to another access point, and another. If that's down, and the entire country is down, it goes to another country. Same thing with a user service. That has to have a global state for all the logins and everything, but hopefully Postgres won't die on us. And for instance, if the search service goes down there, like and it just connects to a new one. But that's not all. So that's just the core services that serves the client. In total, there are about 60 services. It's hard to count, actually. I don't know where I should begin. But there are things like our web service, which also is very important, but not core to the client, and lots of internal tools like content ingestion system. That's handling terabytes of XML, like coming from tables, and read that, parse that, and transcode all those files into tinier, we're using old borders actually, and put that into the system, reporting, analyzing log, and the ad system have different admin interfaces, and they're like these tools for all of the core services. So what tools do we use to build these things? Well, I mentioned Twisted. And actually I said like power of squirrels, but I think of Twisted more like the power of octopus. Like think of like one really busy octopus handling phone conversations. Yes, hello, no, sorry, can you call me back soon? Yes, and hello, no. And it's awesome for writing these services that can handle many different protocols and makes it look easy. But most of our services are not actually that complicated. Like playlist system, definitely, but user system, not that really. It's like, can I log in? Yes or no. So we're actually switching many of these backend systems that are really simple to write to G-Event instead. And we started using G-Event since last year only. And it's really slick and fast, and I look forward to the G-Event talk later this afternoon to learn about the new features upcoming. And I think at least 4 of them, they use the service on social and a few more are using it. So it's handling traffic really well. And it's much simpler, and you don't have to think the octopus way for things that doesn't need octopuses. Who's this? Octopi? How do you say it plural? But we use TurboGears as well for those internal services. We started using TurboGears, but we're actually using Django as well. So we are using all of your frameworks.
That's why we have so many.
Yeah, standards are great, like there's so many. But as I've said, we use Java. The search service using Java, content indexing to build those within instances of Java. And we're actually right now in the process of migrating this huge playlist system to a new playlist system, which is written in Java and Scala. Actually, it's quite nice. It's like you take Java and you remove the bad parts, and then you sort of end up with this language. It's great. But C++ as well, more than just the access point, and I haven't even mentioned all the clients, but they are written in their native language, which you use for that platform, which actually means we're writing clients in JavaScript, because that's what you use when you write PAL programs. DNS, why do we put DNS here? It's like, doesn't everyone use DNS? Yeah, but we use it a bit more than others, I think. So for all the finding all the services, like who needs to talk to, that's you use DNS for. But if you need to find like many different servers, you use SRV records, and we use it for distributed hash table lookups, and it's oh, I want to make an ad for Nick's talk, another employee at Spotify. He will go into a lot of detail of everything I just said. I just touched them briefly. So I think he will touch DNS, how we use it for finding and resolving services. But it's a big part of our system, and if our internal DNS service goes down on site, then that's bad. So we try to keep DNS happy. And the protocols, well, it's usually sort of a JSON or XML over HTTP. That's how everything started. And it's really simple, and the client speaks it, but it's getting overly complicated for some things. So we're starting using Thrift in a few services, and it's something that Facebook sort of came up with. And yeah, that's also a good trick. Like, how do I solve this problem? Like, what did Facebook do to solve that problem? And they have like millions and millions of users, so that usually works. You can do the same with Google as well. That's also good. Hi. And we have our sort of own wrapper to make it slightly simpler and have it Zipper APIs. Maybe Nick will show you some, I'm not sure. Now he has to, because I said so. And ZeroMQ. We actually don't use ZeroMQ much, but we like it so much. We want to use it more. It's just that we have so many systems already implemented with the normal sockets and everything that we haven't switched yet. But there are like a few systems, for instance, in the player system. And I won't touch it, what it is, like nicer sockets, use it, it's great. So storage, how do you store everything? Well, Postgres comes to the rescue. Great, trusted database, which you just install and it works and scales great up to about here. Then you're stuck. So we're stuck with it, and we do the standard master slave replication, hot standby dance, and it works great for us. And we try to make sure that everything that's really, really important is in Postgres and can scale with the master slave way of thinking. And be very, very tiny, so the user service, for instance, stores the credentials and the most needed things for to log in. But for the more services like search, not search, but browse and other weird services that we have, that doesn't need to have this shared state. We use a simple Tokyo cabinet hash table files, and they are really fast. And there's actually one that's faster, called CDB. And I think it's actually a binary config file format from Qmail. So Dr. Bernstein wrote, but we're using that to distribute index files that are up to 4 gigabytes, because that's the limit. But it's really fast, and it's like write once, ship to the servers, and then we usually replace these like every other day or something. And of course, memcache all over the place, the cache things, and the latest, greatest, high-speed Web 2.0 web scale stuff here, Cassandra. And we're actually using it a lot since March, April or something. So I mentioned using Postgres for the important stuff, like user service, but a big part of the user service is storing data, which is great to have about a user, like what genres do they usually listen to, which you don't want to calculate that all the time, but you want to look it up or something like that. And we store those things in Cassandra for the user service. And it's been running in production, and we're quite happy with it. And the new playlist system, the Java Scala thing, also uses Cassandra for the storage. So we use Cassandra both with Python and Java, and it's really great, has a great throughput, but it's not really mature yet. So if you want to use it, and I think you should, it's a really great project, be sure that you know Cassandra well and invest time to actually understand it and have a sort of a team, or at least one person that, as a go-to person, that know Cassandra well and can solve your problems. Because if sometimes you run into some problem and you're like, why is it so slow? And you see something in logs called compaction, and you need to find out what that means. And it actually means that I have to rewrite all the indices to save space and make it slightly faster, but during that time, it might go slightly slower. And Hadoop as well. We don't use it for the core services, but since we have so many users, they produce a lot of logs. And we just stuff that into Hadoop so we can run analytics jobs over it, and all the reporting that has to be sent to the labels, and finding out what genres do they listen to, and like music recommendation system, even though we haven't actually deployed anything yet. But if you know Spotify, I'm not sure many of you use it, but there's an artist page or recommended artists, and these are related artists, and these are calculated Hadoop. And it's also like Java project, but it has a nice streaming API, so you just plug in there and just write the Python mappers and reducers. And it's great. And to store all of our data, of course, we use Git. And I've counted, we have in our GitHub-like SourceForge tool, we have 428 repositories. That's quite a lot, even though we only have like 20 core services. we tend to want to build and modularize every tiny part. And you send the push to Git when you're done, and then you send the command to our build server, and out comes a Debian package. So all of those 600 servers use Debian all over the place. And we love it. I'm actually more comfortable using Debian for deployment and listing than the standard disk details in Python. But it's a more powerful way if you only want to use one platform, and that platform is Debian. To depend on libraries, like for instance, you have the memcache, depend on the memcache library, good, and make sure that it's installed. They can also make sure that the memcache daemon is installed on that machine, if you want it to be installed on that machine. So every tiny little Python module, even if it's not already in the Debian archive, which most of them are, we just stuff them as a Debian package in our own archives, and then we can deploy it to all these servers in a really good way. But it's not enough. Like if you can't depend on a server being installed on a different machine and something like that. So then we use the DNS thing, as I said, like the service knows which services you go to and DNS. But that's still not enough if you want special config, and installing Debian packages on 600 machines gets tedious after a while. So we use Puppet for that. Yeah, it's improving, but it's great. And an example can be like if you write classes with Puppet. So you take the web API class, for instance, you have to make sure that these packages are installed, these config files should be there, and there should be an SSL certificate. And when you run out of, you had high load on the web API machines, and you call ops, hello, give me a new machine, make it the web API class, and then start it up, boot it up with the right class, and pop, you have a new machine, you can test it, and then you just point it to DNS, and it's live and up and running. It should be that simple, and we're quite happy with this environment. But now it sounds like we sort of solved all of the problems in the world, and we're just happy, but there are, of course, many future problems. So, for instance, we need more users, we want more users, and hopefully users need us more. And then we will end up with more scalability problems, and there are so many things that we want to do, so, and some of them you guys already have solved. So thank you a lot for helping us building this awesome tool, even though you didn't know it before, maybe. And thank you for helping the future, and it's so great to be here, and I'm hoping to learn much more, because we're actually quite Python newbies, I'm thinking, when I'm hearing you all talk about Python. So thank you very much.
Questions?
Hi. Are you using plain streaming to write Python bridges applications for Redup, or have you tried Dumbo, EuroPython, or any other wrappers?
Yeah, so Dumbo, I think, was a framework written by Last.fm. And we started using Dumbo. And after a while, and this was like early days, so Dumbo didn't do very much back then. And we were like, no, we want to use it that way, use it that way, and then we started talking to them, and like, let's just write our own, it's just a few classes, and we call it Rambo, actually. It's slightly cooler than Dumbo, but now we're stuck with Rambo, and Dumbo is actually, I think, slightly better than, so we might start using that as well.
Okay, but the base is always streaming, right?
Yeah, but we're using for instance, the recommendation system for finding related artists. The guy who wrote that, like, no, I only use the Java mappers. So we have like a mix of it, but mostly it's the streaming API.
Okay, thank you.
Any other question? Can you describe in more detail what do you use Git for storage of what?
The Git.
Git.
Oh.
Version control system.
Yeah, so we don't actually use Git for live core services. It was just tool that I wanted to mention that we use to store our source repositories in. But we have actually been thinking of, since we re-implemented the distributed version control system in our playlist system, that can't we use that for playlist? And maybe we are using it for something weird. No, probably not. But it would be cool. It's a great data format, and it's fast and reliable. And actually, we built the version control system for the player system, and then you get merge conflicts, and how do you resolve that? But there are only a few tiny operations you can do within the playlist, so we actually made sure to cover all the corner cases so there can never be a conflict. That took a while. So there's lots of pen and paper and lines, and it looks like rabbit ears in the design documents, like many different rabbit ears will happen. Sorry, more questions, please.
Okay. No more questions?
Yeah, we will be standing outside that door. I get it correct. 4 of us. Please stand up. Yeah, and if you have more questions, just come and ask us. And go to next talk Wednesday. Yeah.
Do you have any idea when you will come to Germany and
Do you have any idea?
Italy?
Do I have any idea? Yeah, so as I said, the map of the world there, or the Europe at least. We're going to the US first. And after that, I'm not really sure where it goes, but
first you take Manhattan, then you take Berlin.
yes! Oh, that's great. That's
Can we get coupon codes so that we can access Spotify and if the service is not there yet? Come on.
Yeah, sorry. I know, sad now.
Okay, so we'll chance for some questions. No question, then bon appetit.